and the first half of what you need to remember about trends. So tell me about boiling point. What's the trend for boiling point?
It's the opposite of reactivity.
It's the opposite of reactivity. So who's the highest? How do we figure out?
D block.
Okay, so D block is greater than,
P block.
and that's greater than, which is greater than group 1. And this is for density, for boiling point, for melting point, and hardness. Okay, so when you look at those choices that you have, all right, which one would have the highest boiling point?
Sodium. Sodium.
I hear sodium. Do you have any other options? I like nickel. All right. Why do I like nickel? All right. Let's find out where all these things are. All right. Where's Ni? It's in the D block. Where's K? Okay. Where's Na? Group 1. Where's chlorine? Group 17. Where's fluorine? Okay. Where's aluminum? Group 13, or we can also say, let me fix that. It looks terrible. The P block. And where is neon? Group 18. All right. So if you said that boiling point is this trend, the highest is what? The D block. So which one of these is in the D block? Nickel. That's why the highest boiling point is nickel. Okay, what? The transition metals. Remember your SPDF? Almaja. We've talked about this before, but you're out. You need to do what? Watch the. Did you do that yet?
No, I haven't.
Okay. Do that. Okay. Are you really?
Yes.
Okay. Sometimes I tell you that, and I think you blow me off and don't do that. Okay. So, who's the most reactive metal out of the groups? Okay. So, when I say most reactive, what's the trend there? What?
No.
No. What's reactivity trend? The what? The opposite of that. So, we start with what for reactivity? All right. So, reactivity is group 1 is greater than group 2, which is greater than P, which is greater than D. All right, so how many elements do you have up here that are in group 1? 2. So what happens is you go down. All right, they increase. So how many do you have? You have 2. Who's further down, K or Na? So potassium is the most reactive metal. Okay? You see why I said this gets complicated? Okay, we haven't even done the ones on the board yet. We've only done 2. Other than nonmetals, you can count that as the third one. All right, so who's the most reactive nonmetal? All right, so if we do reactivities for nonmetals, all right, nonmetal reactivity. Who is the most reactive nonmetal? What's that trend? Group 17 is more reactive than group 16, which is more reactive than group 15. So, which group is most reactive up here? 17. Now I've got 2 of them, right? So what's the trend there? More reactive as you go up. Okay, so I have 2 of them. So who's further up? Okay. All right, the least reactive metal. So who is the least reactive metal? Okay, so here's your reactivity trend. Least reactive, that was most. So least reactive would be who? D block. So who's in the D block? Nickel. Okay. Number 5. Which element is the least reactive? Did I say metal or non-metal here? So I could use metals and non-metals, right? So when I look at it, who's least reactive? Neon. All right. All right. And highest density. Who has the highest density? because it's in the D block. Questions? No? You with me?
I thought we were only using once.
No.
Struggled. Yeah.
You guys, never think that on anything I've given you that you can only use it once, okay? Because that is not the case. Okay? Even if it's a quiz or a test. Here, I know we did that yesterday, and I forget if I'll give it to you now. All right. Let's talk the remaining 1, 2, 3, 4 trends. Okay, so that's 1, 2, 3 that we did. So we've got 4 to go, and we'll have all 7 done. All right, so we're going to do atomic radius first. Okay, now, atomic radius. First of all, what is it? It's atomic radius.
I mean,
Y'all are a riot.
the radius of an atom.
Okay, that's good.
Am I close?
I won't say no. Yeah.
For that homework last night,
Yeah.
instead of doing this 2 grade, could you just give us the average 2 grade?
No.
Wait, either way.
Either way, we're gonna
I mean, it's not really because
The nice thing about the 2 assignments is by the time we finish the quarter, most of these quiz grades count as like 1 percentage point in your average because you have so many quiz grades. Okay, so I would not get all work done. Okay, if you drew the graph, you have a 70.
Oh,
Really? I believe
I'm not out to bludgeon your grade or beat you up. If you drew the graph, you have a 70.
It feels like.
Now, if you didn't answer any questions, you're only at a 70. Now, let me say this. Did you label your X and Y axis? If you didn't, you're at 65 because you have to label your X and Y axis. If you didn't, I'd take it off without labeling your X and Y axis. That's a given. You have to do those things. Huh?
I think I
You got about 67. Okay?
I'll put.
Your graph means nothing if you didn't label your X and Y axis.
Well,
It's just
I'm
in
pretty
dots.
sure
There's a line.
You mean like with
I did not
X and Y, or like have like atomic radius, atomic number?
Atomic radius and atomic number.
Okay.
Yeah, if you just label X and Y, that's
That's
a little late. It should say atomic number and atomic radius. But if you didn't, you at least have a 65. I mean, it's not like you have a 0. I'll give you something else over there. I'm not going to let you swing in the wind with 2 zeros. Yours will just be a slightly different graph for the sides. All right, now, because it was just you and Lewis who was absent. Lewis will make it up anyways. Now, although I did see him yesterday, he was in the building. I saw him at the assembly. Lewis, the dude who sits in front of you. I know, you see him so rarely, but that guy who sits in front of you. I think his name's Lewis. I see him.
It's Louise. You just don't care. We don't say that.
Yeah.
That's why I never know who you're talking about.
Well, if he was ever here or corrected me, I might know that. Or maybe one of the rest of you people in here could actually correct me way back in August so I could say it right. And y'all can't say it? Do y'all know how frustrating it is for a teacher to say somebody's name wrong all these years, or for me, all these months, and then y'all not tell me?
We say it every time.
Really?
Yes. You do. You're very intimidating.
I am sincerely sorry. I don't mean to be. But at least tell me how to say the boy's name right. Doesn't matter now. I never see him. I know. It's terrible. All right, so atomic radius is basically the size of an atom, okay? That's a shorthand for atomic radius, okay? So last night when you drew the graph, you were plotting the points for the size of an atom. So when you drew that graph, when it went up, the atom got what? And when it went down, the atom got, okay. Now, we have to know the period trend and the group trend. What, Karina? What?
It looks like a heartbeat.
Yeah.
Yeah, the way it grows.
Oh, okay. All right, that made sense. All right, so when we find the size of an atom, all right, we know that there's a nucleus in an atom, right? Can we measure from the nucleus to the outside of an atom?
Yes.
Sure.
No.
No, because we don't know exactly where the electron is. We think we know, all right, but the electron is actually in an area of probability. Those orbitals that we talked about where the electrons are actually areas of probability. So the way scientists measure radius is to take one atom, and this is going to look weird, and I apologize now, and they take a second atom, and they bond it to an identical atom, okay? I know. They bond to identical. I don't know. All right, they bond two identical atoms together. Now, when they bond two identical atoms together, how do they find the radius? What do they measure?
I don't know.
From one what to one what?
One is wall to the other.
Not the wall to the wall. I heard it over here. Yeah, they measure from one nucleus to the other nucleus. Now, think geometry class. That's not a radius, that's a what?
Diameter.
That's a diameter, right? So then what do they do with the diameter to get the radius? That's right, okay?
I do have a question.
Yeah.
Okay, so you said that we can't measure the nucleus to the outer.
Right, because we don't know exactly where the atom ends because we don't know exactly where the electrons are. We think we know exactly where they're at, but remember, Bohr said they were on rings. Schrodinger said they were in areas of probability.
How do you add another? You lost me there.
The numbers that we learned are where we think they are. It's sort of like right now, if mom showed up to get you, where would Miss Beverly call for you? Here in room 29. Do you have to be here? Yeah. You could be in the bathroom. Guidance could have called you. You could be in the media center. But the greatest chance of finding you is where? Here. So all of those numbers we learned are the greatest chance of finding you or finding the electron in those places. But they don't actually have to be there. Okay? So given that, we can't just measure from the nucleus to the outside of the atom. So it's sort of a rough estimate. So given that, we measure from one nucleus to the other nucleus, which is the diameter. So we just take the diameter and we divide it in half to get the radius. So atomic radius is defined as 1/2 the distance between the nuclei of two identical atoms that are bonded. Okay? Nobody there? Oh, Angel's here. You have a note? You have homework? That's fabulous. Put that on my desk. And you have detention tomorrow also.
How long is it?
15 minutes in the cafeteria. You'll have several friends from in here to keep you company though.
Yeah.
Thank you, sir. All right, everybody got it? Good. All right, so we have to understand the group trend and the period trend. So we're going to do the group one first because I think it's easier. All right, we got it? All right, tell me this. What can you tell me about the outer shell of hydrogen? What's the highest energy level? What?
1.
Okay. What's the outer shell of lithium? Okay. What's the outer shell of sodium? And potassium? And rubidium? And cesium? Fabulous. All right, so what's happening to the outer shell in each of them? So if we draw them, hydrogen has how many rings?
1.
And lithium has how many rings? And sodium has how many rings? So what's happening with the additional rings? What's happening to the size? That's right. So as you go down a group, you add an energy level. So the size or atomic radius will what? What's another science word we can use? What? Increase. So I believe this was question 3 on your homework. As you go down a group, atomic radius will do what? And the reason you gave me was what? Energy level increases. I don't know how many of you might have said something to that effect.
I forgot.
Dante's got 3 points. He's got an increase there. Yeah, it's got an increase. There's another increase. Got an up arrow because Alex is apparently a minimalist in words. Another increase. Taylor's even got the reason. Valence electrons occupy higher energy levels due to the increase in quantum number. Jesus Christ.
Better than nothing. I ain't nothing.
I'm not even sure I can read this one. There's lines everywhere. Now, I might need a degree in how to read the paper on that. Translation. Another increase.
I meant that.
Okay. All right. So what happens in the period? All right. We're going to use the second period here. I'm only going to write 4 of them. So let's do lithium. Let's jump over to boron. Let's jump over to oxygen and then neon. All right. So lithium has 1s2, 2s1. Boron's 1s2, 2s2, 2p1. Oxygen's 1s2, 2s2, 2p4. And then 1s2, 2s2, 2p6. Now, as you're writing that down, what do you notice about those compared to the ones we just did? What's growing? All right, the sublevel and the electrons in it. What can you tell me about the energy level?
It's staying the same.
All right, the energy level staying the same. All right, what energy level are we in? Okay. Does everybody agree with Chris? He said 2. Yes or no?
Yes.
Yes. Okay. We should agree with you. All right. If we look at lithium, what's its highest energy level? The highest energy level is what?
2.
Okay. What's the highest energy level here? What's the highest energy level here? What's the highest energy level here? Okay. So the highest energy level on all of them are 2. So is the size getting bigger if the energy level is 2? No. Okay. So we can all agree that size is not increasing if the energy level is staying at 2. So we're all okay with that. Okay. But is the size getting smaller? How do we decide? All right. Look at your protons. If we look at lithium, up there, lithium has 3 protons. Boron has 5 protons. Oxygen has 8 protons. And neon has 10 protons. Okay? Do the protons have any impact on those elements? Yes. Okay? The protons pull the electrons closer to the nucleus, shrinking the size of the atom. Okay? The protons pull the electrons closer to the nucleus, shrinking the size of the atom. So in question 1, you should have told me the size decreases. Now, if you told me anything about shielding, you told me anything about positive proton pull or anything like that, I will give you credit in number 1. Now, so you should have told me as you go across a period, atomic radius or size decreases. Now, for your visual people, I'm going to put this on a picture in a moment. But that's it in words. All right, we caught up? Everybody had a chance? All right, so, and you don't have to draw this, okay? This is for visual people, okay? I'm a visual person, so I like pictures, always have. Now, when you look at the periodic table, what did I say was going to happen as we go across? What was going to happen to size? In a period, what was going to happen as we go across? It decreases. Okay, so it's going to get smaller as we go this way. What did I say was going to happen as we go this way? What did I say was going to happen as we go down the group? It's going to do what?
Increase.
Going to increase. All right. You got your periodic tables handy? If you don't, get it out because we're going to use it all day today. All right? Now, ignore the F block. I didn't even draw it up here. Ignore it completely. So who on the periodic table is the absolute largest element on the periodic table, excluding the F block? Who? No.
Oh.
Francium. Okay. FR. FR, right there, is the biggest element on the periodic table when we talk about atomic radius. Okay? Make sure you label that as atomic radius because I'm going to draw several of these today. All right? When we talk about radius, that's right. All right? Helium up here would be the smallest. Now, some people, instead of learning the arrows, prefer to learn, oh, francium's the biggest. So the closer I get to francium, the bigger I am. The closer I get to helium, the smaller I am. Okay? So, I'm going to give you a couple of questions. Hey, Kevin.
Sorry.
You're fine.
Winter planning.
Second. So today it's 1:30.
Okay.
Okay. All right. So I want you to find, do you want to do biggest or smallest? Y'all choose. Biggest. All right. So y'all let Chris make all the choices. Y'all should say something. Huh? Devontae said it. What'd you say, Devontae? Okay. All right. Let's say out of these choices, you have CA, BA, MG, and and BE. And number 2, you have CL, AR, and A, and MG. And number 3, SB, TE, AS, and SE. I want you to find the biggest in all 3 of those questions. Okay? Which element has the largest atomic radius in all 3 questions?
Tell me. Contact 2.
All right, you done? I'm just pressing myself, checking my text messages. I hate family dinner. I hate family dinner. I don't want to go. It's my father-in-law's birthday, and I thought we were just going to go to a restaurant Saturday night, so it'd be an hour and I'd be spared. And we're having to go to my sister-in-law's house, which is in Greensboro, so it's an hour over. It's an hour drive back, and I'm going to be stuck there for like 3 hours. So my entire Saturday night is shot. I'm sorry.
That sounds so sad.
It is sad. I don't want to go,
I would drive straight, bro.
and I don't know how to get out of it.
You must be in the heart.
What's that?
Why did you take an hour?
Because they live on the far side of Greensboro, and I live in West Davidson.
Oh, yeah, that makes sense.
Yeah, I was gonna say.
So, yeah, but from West Davidson to Lexington, I mean, even speeding, I'm 12, 13 minutes out. Speeding, so, you know,
Speed, not safe.
I know, my husband drives, so I don't speed. I'll just, you know, play the you drive thing, so I can sit and read on my phone.
You can try.
I know, so I'm doomed. I'm just gonna have to suck it up and.
Yes, I do.
You can hide in the bathroom the whole time. I do that. I do that.
Like me.
My kids won't want to go, and they'll moan constantly.
You said they want to?
Tell them that they have to do it.
Nobody will want to go. My husband doesn't want to go, and it's his family. Why he's been texting me, he's like, can I claim that I have an Apple phone call? I'm trying to get my phone fixed. I'm like, really, dude? That's so lame.
Do it.
All right, so when we look at the number one, where did I put all these elements? In the same way. They were all in group 2. So who's the biggest? BA, because they are bigger as you go down. All right, and so what'd you notice about number 2? They're all in the same period. So who would be the biggest there? And A. Very good. All right, so what'd you notice about number 3?
Put them in the same.
They're in a square, right? They're all the same section, they're in a square. So who's the biggest there if they're in a square? What do you do there? Okay, so you look at, change that a little bit. So you had, because sometimes that throws people off. So you had SB, TE, AS, and SE. So you know as you go down, they do what? So that threw those 2 out. And as you go across, they get what? So that's why that one's out. That's why it's SB. Is everybody okay with that? All right, so we feel pretty comfortable with atomic radius. All right, now, ionic radius. Ionic radius for most people is pretty easy. All right, because there are no arrows here, okay? There's no weird trend that we have to do with arrows. So most people tend to like this one, and then the last 2 are pretty much the same. So those 2 get lumped together a lot, so that makes the last 2 easier for a lot of people too. So, ionic radii. Before we talk about ionic radius, we got to go back and pick up 2 words we talked about, or really 3 words, we talked about a while ago this semester. So, what is an ion? I always love when I go back to this and everybody goes,
Isn't it something with has the same atomic number for different atomic mass?
no, that's an isotope.
I can do it.
That's what I'm doing.
It's not bad.
Is it with the negative charge?
How far back is this? I don't know.
Y'all are all around it, but we just want to shorten it. It's just an atom with a charge.
Oh, yeah.
Okay? So it will have different numbers of protons and electrons because it has a charge. Okay? Protons and electrons will not be the same. So it's not wrong when you say that. Okay? Now, I want to talk about 2 kinds of ions that we talked about. Do you remember the words cation
Yeah.
and anion?
Yes.
Everybody always says that. It's called cation and anion. Do you remember the difference? That's good. Which one's positive? Cation is the positive ion, and anion is the negative ion. Okay? Now, we want to talk about the sizes of these. Okay? Now, when I use the word parent atom, the parent atom is the neutral atom. And that's not a word that I made up or use on my own. Textbooks and test items like to refer to things as parent atoms. Okay? But the parent atom is the neutral atom. Because you might be asked to compare oxygen versus oxygen with a -2 and asked to decide who's larger. Okay? So, if you had to figure out who is bigger, oxygen or oxygen with a -2, this would be considered, first of all, the parent atom, because it's the one that's neutral, and this would be the anion, because this got the -2. Is everybody okay with that verbiage? Okay. So, who would be bigger? Think about things you've learned this semester. Why would the anion be bigger? It's got more electrons. What's this mean right there?
Add 2.
It gained 2 electrons. Think about next week. What y'all gonna do next week? I was thinking we were gonna eat, okay? So,
Sleep.
if we eat a whole bunch, we tend to do what? We tend to gain weight. So, well, I'm hoping to do that myself a little bit. All right, so you would fit right in at my house, Sayla. All right, I swear my children sleep their life away. So, if we gain electrons, we get bigger. Think about it this way. If you gain weight, you get bigger. So, anytime you gain electrons, you're bigger in size. If you lose electrons, you are smaller in size. Does that make sense? Gain weight, bigger. Lose weight, smaller. So if you gain electrons, you're bigger. If you lose electrons, you're smaller. Does that make sense? Okay. Yes or no?
Sure. Yeah. Uh-huh.
Y'all just want me to hush.
It makes sense. It makes sense. I was agreeing with the first thing, like not saying sure.
Okay? What would you do there?
You use the thing we used in the last trend.
All right. Why would we use the thing in the last trend?
Because they're all the same. They all
Elements.
have more. Yeah, they all have more protons.
Small.
They do all have more protons. Yes.
So they're all small.
What else you notice about them?
Oh,
The same group.
They have two.
How do you know they're in the same group?
Because they all have two.
It's B.
Me too.
Is it B?
They're all in the same group.
Yes.
All right. I can't even figure out what I did there.
You're not.
We're erasing that.
Smallest is BE.
Yeah.
Let's try this.
B.
Yeah.
I need to swallow. Are you sure?
Okay, they're all in the same group. So, how'd you know they were in the same group?
Because they all have +2.
They all say +2, okay? Now, you could actually look up the oxidation numbers and you could find out, oh, the elements are in the group by looking up the symbols, yes. But the fact that they all say +2 right here tells us that they're in the same group, okay? Now, if they're in the same group, how do you figure out who's smaller? That's right. You know, as you go down, they get bigger. So who's at the top?
Beryllium.
BE will be the smallest. Okay? Does that make sense? Okay. I don't know what's going on with that mess. Okay? Everybody feel okay about ionic radii? Because that's all there is to ionic radii. That's why I said earlier, most people like and are okay with ionic radii because there's no arrows, there's no weird stuff that goes on with ionic radii that throws people off like atomic radius or these two.
And this is gonna tie in with what I'm about to watch from yesterday.
The stuff we did in the opening is what was yesterday. Okay? Did I lose you in the opening? Or did it sort of make sense? Kind of. I think if it kind of made sense in the opening, if you go back, because it's only going to be probably 30 minutes or less that you have to watch, because you'll buzz through the stuff at the beginning, and it's right at the end, probably a half hour. Then you'll just watch that half hour, and then you'll be okay. Okay? And if you don't want to have to take notes while you're watching it, just copy somebody's notes and then just watch and then fast forward through the parts you don't need. Okay? And that'll make it faster for you. Because I know with basketball and everything, you've got a lot going on. So copy somebody's notes and then just watch the parts where I'm explaining, and then it'll make it faster. Okay? Does that make sense? Okay. Because you just need the instruction piece where I'm actually explaining to you how to read the trend. Okay? All right. Ionization energy. All right, 2 left to go. Now, ionization energy and electronegativity are nice, because they're the same, but there's a glitch that I'll have to talk about when we get to electronegativity. Okay?
And I have to remember,
Yeah, you gotta remember the glitch when we get to electronegativity. You know I'm not gonna ignore the glitch.
you could.
I could, but I'm not going to.
Should.
I'm not going to. Give me a voicemail. People. It doesn't do you any good to call me if you don't leave me a voicemail. Yeah, they did good.
If I do, I have to redo it somehow.
All right. Okay, it's the energy needed to remove one electron from an atom. All right, it's the energy needed to remove one electron from an atom. The energy needed to remove one electron from an atom. Now, all of this stuff that we're doing today and practicing, you're actually going to do a puzzle with it tomorrow. It's going to count as a lab grade. Okay? You're going to use some fake elements and use clues to put these fake elements in the correct place on the periodic table using everything you learned in the last unit and what we've been practicing yesterday and today. Okay? You get a partner, and you and your partner each get to pick one periodic table. So you and your partner get 2 periodic tables total, and that's all you get, no notes. Okay? And then you're going to use these clues to put these fake elements in the correct place on the periodic table tomorrow. Okay? Are you good with that?
Sure.
I knew you would be. Y'all are super smart.
I'm literally doing the smart.
You're super smart. Well, you're somewhere between smart and super smart then.
Better than you.
So find a word that fits in between.
9 grades.
All right. Diamond, I need you to work with me on this a little bit over there. All right. So for the period trend, I'm going to draw a scaled down version of the table. Yeah, because we only need one little number written in to explain the trend. All right, so how many electrons in the outer shell of group 1? How many in the outer shell of group 2? In group 13? In group 14? In group 15? 16? And 17? In group 18? Okay, so tell me where they really want to lose electrons. Where do they really want to lose? Group 1 and? Okay. All right. So right here, they want to lose electrons. Okay. Where do they not want to lose? Okay. 17, 18. Okay. It's okay. I knew what y'all meant, but those would be groups 17 and 18. Now, on the test, just fair warning, when I say which groups, I will have group 17 and group 7 as an answer choice. Okay, I just throwing that out there so that when I refer to this, I will call it group 7 and group 17 as an answer choice. So those of you who constantly refer to that as group 7, 7 is an answer choice. Is it the right answer choice? No. It's group 17 and group 18. Okay? So these do not want to lose electrons. Okay? Now, so if we know that these groups want to lose and these groups do not want to lose, what do you think about their energy? Okay? Would this require high energy or low energy to lose if they want to lose? That's right. Okay? This will have low energy if they want to lose electrons. Now, if they don't want to lose and you have 8 because you have what you want, is that going to be low energy or high energy? That's right. This is going to be high energy. So, what's going to happen to ionization energy then is we go across the periodic table. It's going to increase. All right, so as you go across the periodic table, ionization energy will increase because the element is closer to having 8 electrons in the outer shell. What's the name of that again? Octet is a good word, yes. I think that's a fabulous word. Okay, so we use the word increase, closer to having 8. So we increase as we go across because we're closer to having 8. All right, everybody got it? Mm-hmm. All right, so can we do the group? I don't think we need to draw configurations. Debating. Let's do 3 of them. Let's do H. Because I don't want to draw a whole bunch. Let's do sodium, and I'm going to leave a little space for a reason. Okay. Now, just like with atomic radius, what can you tell me is happening to the atom?
Its outer shell is growing.
Okay, its outer shell is growing. All right, so, and I left space, but you can see this is one ring, this would be 3 rings. This would be 5 rings, right? Now, are any of y'all going on Mr. Jessup's field trip tomorrow? Anybody in Jessup's class? I got one. Okay. I know he's trying to move that. I asked him yesterday, I was like, y'all still going on that thing? The forecast isn't looking real friendly. 100% chance of rain, a high of like 39, and it's an outdoor field trip. They're going to a battlefield in Milford County at the courthouse. It's a great field trip. Unfortunately, Alex may come back with pneumonia after he spends all day, 4 hours outside on the battlefield in 39-degree weather and rain. So, oh, y'all must be an AP.
Yeah.
No, they
No,
don't.
he might be taking y'all somewhere too.
He's not.
He's taking them at the moment. But anyhow, my point in the story is, so I think there's like 40 some kids going. And I think it's just him and the bus driver, chaperones. So if Mr. Jessup and the bus driver were taking hydrogen, he'd have to keep track of how many people. Well, I'm pretty sure Mr. Jessup and the bus driver can keep track of one person, correct? It's fine.
Okay.
I might come over there and snack on with you, but other than that.
I see.
All right, so sodium, it's okay. Sodium is 11. Could he keep track of him and sodium? Bus driver and Mr. Jones, could they keep track of 11? Yeah, probably do that. But with rubidium, they're getting down there with 37. It's getting a little harder with 37, right? All right, so it'd be a little harder. And if we kept going down the group to francium, then we'd be up at 87. Oh no, somebody's sneaking off at 87, right? Devontae's sneaking off. All right, remember that. If y'all get to go anywhere with AP, somebody keep a leash on Devontae. All right, this is why AP's not going anywhere. Devontae's already plotting. All right, so as you go down the group, and size increases, it is easier to remove an electron due to its size. Okay? As you go down the group, it's easier to remove an electron. So, if it's easier to remove an electron, what would happen to the ionization energy if it's easier to pull off the electron? Would ionization energy increase or would it decrease if it's easier to remove one? It decreases. All right? So ionization energy decreases as you go down the group. Okay? Because it's easier to take one off, it's going to be less ionization energy. Okay? Because it's much easier to lose one. In a small group with 2 or 3 people, you're not going to lose an electron. But when you get out on these outer rings and you're further from the nucleus, it's much harder for that element to hold on to those electrons. It's much easier to lose one. Okay? Particularly if you take, Antoinette, she's sort of small and tiny. It'd be easier for her to get hung up, lost behind a wall, or a cannon, as it were. A cannon. We'd be on the battlefield. You could easily hide behind a cannon and he'd wander off with a group and then you could sneak away. You wouldn't do that though, would you?
I know a funny story.
What?
When we went to Washington, Jada got lost in the cemetery.
You got lost in the cemetery? They're only headstones.
The Arlington.
Oh, well, that was a big one.
Yeah, she got lost. Or the bus waiting. We were going to a play, but they had to, I was working hard, wait to start the play until we got there. Because they had to find it.
How old was Jada?
We were 6th grade.
Oh. How long was she lost?
For like 30 minutes. Like 30 minutes. But like, I had a map and I couldn't read the map. I was like, where am I at? And like, I couldn't figure it out.
You want you have a map?
Yeah.
Oh, that's good.
Okay. Map reading skills. Did they work on your map reading skills when you got back? Oh,
But I can read the map. That's a good thing.
that is a good thing. All right. So, same thing we did a minute ago. You know, Ms. Wall's visual. I like pictures. So what happens is you go across this time.
High energy.
Low to high.
Okay, so as I go across, it did what? Okay, it increases or gets bigger.
Wait, what is this?
All right, which one is this one? Ionization energy. What happens as you go down? All right, did you notice anything about this one versus what we just did?
It's opposite.
It's opposite of which one? Opposite of atomic radius. No, I haven't done the glitch yet. Now, I'll be honest with you. I don't keep ionization energy in my head. I don't know that one. I only keep atomic radius in my head. The one I know. I know it frontwards and backwards. And in my head, I know what? It's the opposite of atomic radius. So when I do my test, I write atomic radius, decrease, increase. So when I need to do ionization energy, increase, decrease. So if you actually looked at my answer key for the periodic table test, I got these arrows all over the place because I know my learning style. My learning style is visual. I need these arrows, okay? That's how I keep myself straight. I'm 49 years old. I've taught chemistry for 28 years, okay? I know my learning style. This is how I function. This is not how most of you probably function. You need to figure out your learning style and how you function at your age. You've got years to go in school for most of you if you're going on to school. Most of you are probably going to college, are you not? The sooner you figure out how you can study and be successful, the easier it will be on you, okay? So, master that so that it's easier for you, okay? Now, do we need to do some practice with that or can we keep going? Keep going. All right, electronegativity, last trend. Now, this trend is the one we will use late in class tomorrow to start bonding. It's abbreviated EN so that we don't have to write the word out all the time, okay? Now, it is a measure of an atom's ability to attract electrons to itself in a bond. This is the one I like to talk about with tug of war. Okay? So let's say we have hydrogen and chlorine. Okay? And they have these two dots. Those are the electrons that they're sharing between those two atoms. Okay? And I'm going to pick on Anthony and Alex over there. Okay? They're going to have a tug of war. It's elementary school, field day. Okay? Everybody in here has had tug of war. Watched it on field day, right? Only it's a two-man tug of war. Anthony's on one end of the rope, Alex is on the other. Okay? One of them's hydrogen, one of them's chlorine. All right? And I want you to tell me who's who. How many outer shell electrons does hydrogen have? How many outer shell electrons does chlorine have? I know somebody didn't just say a lot. Okay. So, hydrogen has 1, chlorine has 7. What does hydrogen want to do?
Get one. Get one.
All right, it wants to lose 1 because it's only got 1. It's easier to lose. Okay, chlorine wants to do what? It wants to gain 1. Okay, so wants to lose, wants to gain. So, which one's Alex? Which one's Antoine? Huh? CL is Alex. Poor old Antoine is getting ready to be drugged across the field. All right? Because, I'm just telling you the truth. Chlorine has 7. These little electrons are being pulled towards the chlorine, while hydrogen is saying, here, take the electrons. I can't hold them. I'm a weakling. So here are the 2 electrons. I'm giving mine to you. Okay? So, electronegativity is a measure of how much pull I have. Chlorine has more pull because it has 7 electrons. Hydrogen only has 1 electron. Does it have much pull if it only has 1 and it wants to lose? No. It's pulling on the rope, but is it pulling very hard? No. Antoine would be pulling on the rope. She's got muscles, but would she be doing a very good job? No, it'd be sort of like me right now pulling on the rope with my left hand. Would I be doing a good job? No.
You'd be doing amazing because I believe in you.
Okay.
Stop doubting that left hand. You're going to need it. You need it.
They check my grip periodically when I go to physical therapy. It's actually called occupational therapy. I just call it physical therapy. And I've made huge strides in the last month. I have. You know, they check my grip on this hand and it's about 70 to 80. I assume that's normal. I have no idea. My father-in-law's in about the same boat because he broke his wrist a year ago. This hand, a month ago, what do you think it was?
30.
30.
Alex got it right. What was it? It was a 3. I know. My husband does not need to worry about any spousal abuse with my left hand. So in the last month, I've gone up to 12, and this week I got up to 15. Yes, you don't have to worry about any powerful handshakes. You're lucky I can hold your hand. All right, so I could hold the rope. Rarely can I squeeze it. And at the moment my hand's so tight this morning, I don't even think I can squeeze the rope. So Antoine could drag me around the room at the moment with a tug of war rope. So I broke my wrist. Yes, my distal radius in 2 places. Yes. And most people, you know, come out of a cast and they're fine, and unfortunately I'm not. So it is what it is. And then I have all this nerve damage, and then I have all this weird dark hair that grew in as part of the nerve damage in my, from here to here, I look like an Italian man. So yeah, it's great. So I'm having that waxed off next week. It's fabulous. All right, so
Oh my God.
I'm telling you, my kids are completely grossed out by it. We are. Now, here's the glitch. Because the glitch, I'm going to put it up here. So, what did we just say about electronegativity? All right, stop. Slouch it over to your desk. We're almost done. So, what happens as we go across? It increases. All right, it increases. What happens as we go down? It decreases. All right. Now, here's the glitch. Helium, neon, and argon. These 3 have no negativities. Okay? They have never formed a compound. So they do not have an electronegativity. So the problem we have is ionization energy goes all the way to group 18, right?
Yes.
Electronegativity stops at fluorine. Fluorine's highest is 4.0. Okay? Fluorine is the biggest. Here, let me use black since that's already in red. F is the highest. Okay? Fluorine is the biggest at 4.0. So you got to remember electronegativity goes across and it stops at F. It does not go to the noble gases. That's the glitch. Okay? Can you remember that?
No, I don't even know.
You don't even know what?
Can you repeat that?
Ionization energy increases all the way across the table into group 18. So if I ask which one has the highest ionization energy, you go all the way across and you can pick anybody in the noble gases. Okay, so it can be any group 18 element. Electronegativity cannot be anybody in group 18. Fluorine has the highest electronegativity. It stops at group 17 because the group 18 elements have not all formed compounds, so they don't have electronegativities assigned to them. Okay? It's sort of like you don't know how strong kids were in the tug of war because they never got off the bench. They've never participated before. So you don't know if they can be good at tug of war. All right, so now we're going to do two things to practice. We're going to do some practice questions first, and then we're going to do plickers. All right, I have Kahoot for Denasia, but we're not doing it today because it's timed, and today will not work well with time because y'all are not fast enough yet to do it time.
Just one time.
And do it on the phone. And you finish Miss Thornhill's work. As long as you're done, you're fine. What'd you say?
Is that 4.0?
Yes, 4.0. Okay, what?
It was wrong too. Yeah. Who's on that pro team? We whooped y'all, bro. We put a record on y'all.
All right, find me some answers.
He was on the team, that's no problem. I wouldn't do it now.
You may have a question for me? Anybody? Hey, baby, this is Kristen. Hey, you wanted to make my appointment? Sure, I don't have an issue with it. I can't do tomorrow because I have a dentist appointment, but I can do Friday. Do you have 4:30 ever, or is it booked? Okay, I can do 5. I can't make 4 because I don't get out of school at 3:30. There's no way I can be there that early. Okay, I'll see you at 5. All right. You're welcome. Bye-bye. Yes, we are. Are y'all ready? You got 2 more? All right. All right, so the first video, I need 2 more minutes, or 3 more minutes to finish the last 2, or you ready?
I'm good, huh?
Alright, I'm just grading your papers. I can easily stop. Alright. Let's minimize that. Save changes. Cancel. This here at the moment. Alright, make that bigger. Alright, who is the most reactive? What can you tell me about MG? Where's it at? Alright, group 2. SR. Group 2. What can you tell me about AL? Alright, you can say group 13. Alright, it's also what we call the P block. And what can you tell me about S? It's a non-metal, so we should just take it out of the running altogether. So if we're going with most reactive, who's more reactive, group 2 or the P block? Group 2, okay? So we've got 2 of them in group 2, so what's the rule if they're in the same group?
The one that's closer to the bottom.
That's right, more reactive as you go down. So what happens as you go down? Who's more reactive? SR. Everybody okay with that? Okay, so non-metal. What's the rule for non-metals? What is more reactive?
7. Oh, more
Okay.
reactive.
Yep, so group 17. All right, so all of these are in group 17 here.
Whichever one
So-
closer to the-
What do you know about this one?
Isn't it that's a metal?
So that's out. All right, so it said least. So what's our rule for group 17 and non-metals? Up or down? That means that would be more. So who there would be the least then if they get more reactive as you go up? That's right, closer to the bottom. So I is closer to the bottom. All right? All right, largest ionization energy. What's the rule for ionization energies?
It's opposite of the Tom Ray radius.
All right, so as I go across, they do what?
It's smaller. Bigger. That.
One of the two.
Yes, one of the two.
Increase.
It increases. And as you go down, it does what? Decreases.
Yeah, I did this round too.
So Na is over here, and then Mg is beside it, and then chlorine is over here, and Ar is over here. So based on that placement, who would be the largest? Argon. All right. Atom or ion is the smallest.
Because it's
That's right. That means it lost electrons. It's got to be that one. All right. Smallest radius. What happens as we go across? Decrease. As you go down, it increases. So if we look at where they're at, we have K, we have Ca, we have Rb, and we have Sr. So we know as we go across, they get smaller. So as we go down, they get bigger. So who's the biggest? Oh, smallest. Sorry, I read it wrong. We're doing smallest. So scratch that. As we go across, they get smaller. So let me redo that. So K and Rb, Ca and Sr. So I said smaller. So as we go across, they get smaller. So that means the bigger ones are out. And so as we go down, they get bigger. So that means Sr is out. So smallest will be Ca. All right. Highest melting point. would be the trend we worked on yesterday. So do you remember what we said this morning, or is it still really mushy? Okay, so somebody tell us what it is so we can catch Amaja up. Who's the biggest? The D block is greater than, which is greater than, group 1. Okay, so where's the FE at? All right, where's SR? And where's CS?
1.
And phosphorus is? It's in the P block, but it's a non-metal. So if it's a non-metal, should we include it? No,
I mean,
we shouldn't. Okay?
Wait, it says element, so why not?
Because this
It's
trend
not the highest one, though.
is for metals, first of all.
Oh.
Okay? That trend is only for metals. So chuck it if it's a non-metal. All right? So who would be the largest? Iron, because it's a D block.
Yes.
But this trend is for metals. So if it's a non-metal, chuck it. Everybody got me on that?
Yeah.
Okay. Which element will have 4 outer shell electrons? That should be an easy one for us. Huh? Because it's in group 14. Okay. Who will have a +3 ion? All right. For those of you who might not have remembered that the other day, that just means oxidation number, right? All right. Which element has the largest atomic radius? Okay. Remember, it's the same one we have up there. So that is decrease and increase. Look at where they're at. K is in group 1. Manganese is in the middle. GE is here. And KR is over here. So we're going across. So the biggest would be K. They're on the same period. All right. Smallest ionization energy. Ionization energy does what? Increases. Decreases. So looking at where they're at, you have CS. You have Na above it. You have CSI over here. And CL over there. So given that, who will have the smallest? CS. Questions? Feel okay about that?
Yep.
Think we can play some flickers?
We can attempt.
We can attempt. Okay. All right. Let's see if we can do this. Grab the flicker cards and my
Same
iPad.
number as last time.
Yeah, your numbers will not change, but I'll pull them back up in case you forgot. I just spread out like 1 through 20. I don't think we had anybody at 21, but we might. You were 21? All right, spread out 1 through 21 on the desk so people can find them. I grab my iPad. Now, mind you, when we finish this up, yeah, I'm going to give you a homework assignment.
Okay.
Okay, yeah.
Or that's maybe with your pillow.
Everything
Oh, you
else.
guys do?
I've seen some of it, but
Okay, bet. I ain't gonna have
And make sure you have periodic tables you can see handy. I put some numbers in, but not a lot of them. I put more atomic numbers in the, yes. Get ready to. I gotta pull it up on board. You don't remember your cards, just be patient. I'm getting it. I never played this.
wait, I do know my
14
number.
to every other class. So I'm going to.
I'm like the weirdest number. In the twenties, I'm 23. But your name is. Is every class?
Oh,
No, but it's like.
Oh, I don't want to do this one.
Like,
Every time I say about us, about football.
You're not 14, Devontae. You're 13 in this group. Okay.
Oh, I'm number 11. No, I'm not. Number 11.
I forgot to put it on the list.
Everybody got their card? Everybody got their card?
Expectations for some period.
All right. Now, for those of you who were not here last time and didn't do this, okay, this replaces the old clicker system where you had to use the card and point at the light. So, Jada, I know you said you weren't here. You see how the card has A, B, C, D on it?
You just turn it that way?
So if you want it to be A has to point up.
Okay.
Okay?
do we do the one that's closest to the bottom?
It depends. If it's a metal, it's at the bottom. If it's a non-metal, it's at the top. That's the part that we did on, what's today? Wednesday? Yesterday. Metals and non-metals for reactivity are different.
Okay, non-metal at the top, metal at the bottom.
That's why I said, get the notes and then go back and, at least buzz through and watch so you see the discussion on that.
I'm gonna just take it.
Your fingers in the mic. Miss Donation. Yep. All right. All right. So we have 9 right answers, and then we got 8 wrong answers. So, we ain't hitting a whole lot here. We're about split. So when we look at this, all right, what can you tell me? All right, group 17, it says non-metal. Let me change the color here. So I got a color I can work with. All right, it says non-metal. So we know all of these are non-metals.
Yeah.
Group 17, group 17, group 16, group 15. Which group is the most reactive?
17.
So that's why this one and this one are out. Now, Almisha just asked what happened if they're in the same group. What do we say about non-metals?
Most reactive or closer to the top.
That's right. More reactive as you go up. Who's more reactive as you go up? Chlorine or bromine? Chlorine is further up, which is why it's chlorine. Okay? It should be an easy one for us. I better have 100 on this.
Oh, never mind.
It's amusing to me how many of you use the internet to do that. How many of you didn't? Ones who didn't have 100. Ones who did have a 96. One of the assignments. The internet has 2 of the answers are wrong. Clearly I'm not getting my wish of 11-6. Valence electrons means what?
Outer shell.
Outer shell. Okay? So there should only be 1. And some of these aren't just from today, because remember, the puzzle will include stuff from the last unit also. So,
Yes.
Easy.
tilt it a little more towards me, Devontae. There you go. I got it. So you quit? Yeah. What you gonna do if you quit? You're not taking a nap.
I'm about to take a nap.
Wait, no,
You was Owen and Indiana.
wait, no, I didn't. Yeah.
All right, that was at least better.
Oh, gosh.
All right, so you're in. All right, we
Uh-oh.
lost that connection. All right, so we're in group number 16, so we should have had 6 dots. Let's see here. Okay, look this way a bit. Tilt it up. There we go. All right, not terrible. All right, so questions.
Yeah.
Period. All right, periods count this way.
Oh, no, okay.
Alright.
I know.
Period. The periods are important for tomorrow. They will give you clues based on periods. So hydrogen and helium are period 1, lithium through neon are period 2, sodium through argon are period 3, potassium through krypton are period 4. That's all the green I'm seeing so far. Hallelujah, we finally got one that everybody got right.
Yay.
I better have 100 on this one too. I'm gonna be highly perturbed. Good. misbalanced. There we go. All right, I got 2 wrong answers. Both of the ones that were wrong, people picked metalloids.
Oh, man.
Oh my God.
SI and SB were the wrong answers that people picked, and SI and SB are metalloids.
Hey, sis.
Calcium forms what? Calcium forms what kind of ion? Positive 2 because it's in group 2.
Yeah.
And copper is a transition element, so it does what? It varies. Okay? Now we're not all going to be review people.
Oh.
Maybe easy one.
I thought.
I'm looking, wait, let me.
I can't be an easy one.
Oh.
Is chemistry ever what? I guess. The old timers might. Just in the nature. Okay. I had 2 people pick neon. What did they forget?
It can't be.
It can't be a normal gas.
Can't be a noble gas. Only ionization energies have noble gases. Okay? That's that glitch. Somebody touch the mouse. Alex, if you will, I'd appreciate it. It's coming. Hmm.
Chris.
Hmm.
Do we have homework today? Yeah, I did.
You said we're working on the
Oh,
ground.
sorry. Oh, what paper? No, this is English.
What paper?
What do you mean? It's not no paper.
Alright, what did we forget?
It's like a worksheet.
I love when y'all disagree on what homework is. Cracks me up.
It's a worksheet.
What did we forget? For the 3 people who forgot, is it chlorine? Ionization energy goes all the way to the what? all the way to the noble gases. Y'all got electronegativity and ionization energy backwards. I guess she's got time.
Yeah, time to procrastinate. Okay.
So we got three who, all right, calcium is in the right group, but what happens is you go down the group? It gets bigger. So that's why it's not calcium. And sulfur, you're at the wrong end of the table. You pick the largest radius or electronegativity. All right. All right, so we got 2 aluminums, 2 potassiums. Potassium would be the what? Most reactive. And aluminum is a P block element, so I don't know why we didn't pick that.
Because it's in.
It's in group 1, so it would be the most reactive metal. And the question said least reactive. So the noble gases are going to be the least reactive because they have 8 electrons in their outer shell. They don't want to lose or gain any electrons. All right, we'll do one more after this one, then we're going to stop.
Okay.
And then I'll see what I want to give you for homework. Well, you got to at least study at a minimum, but I'm leaning towards something at least to help you practice for the lab tomorrow. I just got to decide what it is. Say what?
Worksheet like that.
With a multiple choice?
Yeah.
I got something like that. I can do that. Texting away over there. You gonna answer the question now?
Mm-hmm.
It's like the last one, so you might have a hard time with this one because it's yesterday. Did I get you? I know I went by a while ago when we were still thinking. Next thing. Let's give it your best guess. All right. So when you look at it, all right, most reactive has to be in what group for non-metals?
Oh, I see that.
17, right? And what happens as you go up or down?
When you go up
That's right. When you go up, it's more reactive, which is why it's chlorine. Bromine is further down. Okay? All right, one more and then we're going to stop. Here, I'll even give you one that's got the atomic numbers written in. Okay, just missing Neil and Alex. Gotcha. All right, so we're all over the map. Lowest density has to be where? Group 1. So group 1 would be sodium. All right, the highest would be the P or D block, which is PD, palladium, which is where the other 5 of you fell because you picked the highest. And then the 3 outliers there, I don't know why y'all are in calcium and aluminum because y'all are in the middle. All right? Yeah. Questions? All right. So, put your cards back for homework. Alex has asked to have multiple choice to practice for the lab tomorrow, which is fine. I have another one of those. Oh, homework. All right. Come here.
Are you allowed to go to the bathroom during this testing?
Yeah, as long as you don't go anywhere near the upstairs hallway.
Okay, well, can I go to the bathroom then?
Water is a yes. Take the vest, and I will not charge you a hall pass because we're here forever.
Okay, no, I was gonna ask my senior because they ain't gonna say.
Right. Now, y'all cannot go in droves, but
Okay,
one
well,
at a
I'm
time.
gonna
All right, so
I called Nick.
this.
Online.
I already got some wrong.
But she didn't have patience.
I'll let you go after.
Thank you.
A little cheesy, but I cut down a lot of cheese. Basically, remember. You don't use the first one. You're like, thank you. No, I want it. And all the other state that tells you it's a solid. It's a solid. What we call those, still solid. I introduced you to that. I gave you the same thing I gave you. This one. Don't laugh. Exercise. Turn it this way or this way. I don't care. Okay. It's just a different way I made that. It's the same concept. Okay. You're going to number 154. Put the atomic number down here. 0. 54. I'm in the space. 54. Number by 2. 2, 4, 6, 10, 12. Okay. And then you're going to go ionization there. You can go from. So what is number?
I walked in, I was like,
Around
I didn't even recognize him, bro. I walked all the way in, I was like, oh,
200, 300.
oh, that ain't Curtis. Like, it's Curtis. Not that, bro.
Okay. And then you're gonna plot the
They
point.
do is make you like
Your
sleepy.
graph. I mean, up, down, zigzag.
I actually.
You should. You had that lab.
We've done the information.
I forgot we had a lab.
I did it.
Did you know what time?
I did it.
And I can do it now.
You can.
Well,
Yeah.
and I want to.
No, I mean.
But-
it was worse than that.
What? What is this gonna be? Some kind of crazed, gotta go to the